Okay, in section 7.4, we're also going to simplify, so we need to know the properties of rational exponents. So if you see a problem that says a to the m times a to the n, you should know that we have to add those exponents to simplify. So it'll look like a to the m plus n. So in this example 6, we're going to add the exponents. So 8 to the 1/3 power plus the 2/3 power equals 8, and if we remember our adding fractions, we're just adding the numerators. So that's 3/3, which means we have 8 to the 1st power, which is 8. And you don't have to actually leave it as a 1st power. You can write it without it and just call it 8. So again, we added the exponents. We added the 1/3 plus the 2/3 to get 3/3, and then we simplified that. If we get it in this form, where we have a raised to a power m, and then it's inside parentheses raised to a power n, we're just going to multiply those exponents. So it'll look like a to the mn. So in example 7, we got to write it out. So that would be 5 to the 1/2 power times, and then we're going to do 4, but we're going to put it over 1 so we remember what to do with our fractions. And that equals 5 to, well, when we multiply across, 1 times 4 is 4, 2 times 1 is 2. So 5 to the 4/2 power. Remember, we can do 4 divided by 2. That gives me 2, so we know it's 5 squared. And if we really want it simplified, we know 5 squared equals 25. So we got all the way from here to 25 by simplifying, because we multiplied the exponents. The next example, we have ab in parentheses raised to m. Whenever you see them in parentheses raised to a power, we want to distribute that exponent. So it looks like a to the m, b to the m. So in example 8, we have 3x squared to the 1/2 power. So we want to take 3 to the 1/2 power, and we want to take x squared to the 1/2 power. And I'm going to put x squared in parentheses. If we think back to what we just did earlier in 7.4, we can write 3 to the 1/2 power as a radical, square root of 3. And we can also write x squared to the 1/2 power as a radical, square root of x squared. Now the way we simplify this is we say, what can we actually get the square root of? Well, we can't get the square root of 3, but we can get the square root of x squared. So we would end up with x coming out, but the 3 has to stay inside that square root. So our final answer would be x square root 3, because this could be simplified a little bit more. If we see a negative in our exponent, like our next example, to get rid of the negative, we're going to make a fraction. That's all you have to do. Put 1 on the top, put everything else under the 1, and you can remove your negative. So it would look like this. 1 over a to the m. So in our example, 9 to the 1/2 power, there should be a negative here. 9 to the negative 1/2 power, so I'm going to take and put 1 over 9 to the 1/2 power. Now again, if we go back to our previous lesson, we know that we can write the 1/2 power as the square root of 9. And if we simplify it even further, we know square root of 9 is 3. We've got 2 more sections to go. A to the m over a to the n. When we see this, we need to subtract the exponents, because this fraction line reminds us of division. Division is the opposite of multiplication, and when we multiplied, we added our exponents, so when we divide, we subtract our exponents. So look to the a to the m minus n. So for example, 10, we have n to the 3 over 2 divided by n to the 1/2. We can rewrite that as n to the 3 half minus 1/2. 3 halves minus 1/2 gives us 2 over 2. And again, just like in the first example, when we have the same thing on the top and bottom, that means it's to the first power, which means we just have that as our answer. And in our final example, we have brackets around a fraction, and it's raised to a power. When we see this, we're going to have to distribute to the top and bottom. So we're going to distribute the m to the top and to the bottom. So for our example, we have 8 over 27 raised to the 1/3 power. So that means I need to have 8 to the 1/3 power over 27 to the 1/3 power. And again, if we go back to our previous lesson, 8 to the 1/3 power is the same thing as the cube root of 8. 27 to the 1/3 power, same thing as cube root of 27. And then you look and see, do we have any perfect cubes? Is there anything we can simplify? But yes, the cube root of 8 happens to be 2, and the cube root of 27 happens to be 3. And that is it.